can? Okay? Yeah, right. Okay. So, good morning, ladies and gentlemen. Good morning, ladies and gentlemen. I'm sorry we delayed, but good morning. I hope you're all doing well today. My name is Ahmed. I'm part of the organizing committee of the Zak World of Façades conference. I'd like to thank you all for being here present at this event and being patient. We've had a small technical delay, as I mentioned to you. I'll quickly introduce the Zak World of Façades events to you before we get into the presentation. So, we basically started the Zak World of Façades conference way back in 2012. We've completed around 83 editions. This is edition number 84 for us. We've done events in 27 countries around the world. We have events planned in 32 countries. We should have completed 100 plus editions and almost finished our target of 32 countries had COVID not hit last year. And this technically should have been the event which should have been our 100th event last year, but it didn't happen. Fate had other plans, but here eventually we are. We had a pathetic year, not only us, most of the event organizers and most of us had a pathetic year last year. And for us as a business was really bad. We couldn't pull off any physical event. Yes, we did our bit with virtual events, but personally I'm not a big fan. So we started doing in-person events. From March this year, we started in Dubai. So we started looking at countries which were recovering from the pandemic and which had open up permissions to do events. So we did 6 events, and New York is our 7th event for the year. We did events in Cairo, in Dubai, in London, in Frankfurt, in Mumbai. So this is edition in Doha. So this is edition 7 for us for this year and the last one for this year. I hope we can complete our 2020 backlog and get to new places in 2021. Of course, this is our plan for 2022-23. Earlier days I used to give a date to all these events, but unfortunately due to uneven recoveries, we are not able to commit on dates. But yes, we have 10 to 12 of them planned in countries which have opened up and recovered at least, or recovering from the pandemic. For North America, like last time, we had planned for a couple of more events apart from New York. This is our 3rd edition in New York, so we have events planned in Dallas for next year, in Toronto, in New York again, Seattle, which was again planned for last year, and New York in November again next year. I'd like to thank our event partners who have supported us for this year. AGC, this is the chemical division of AGC. They have a brand called Lumiflon. They are one of the associate partners of this event. So I'm going to announce all our associate partners first. AkzoNobel. AkzoNobel is a coating manufacturer of liquid and powder coating, a global player. Codina is a manufacturer from Spain. So after the 8th November uplifting of the ban, we had our European friends coming and supporting us last minute. Codina is a manufacturer of mesh for facades. Cosentino is another Spanish company. Their cladding product is called Decton. Dow is a high-performance solutions provider, mainly for the ceiling and air barrier solutions. We have Facades X, who is a distributor of various cladding materials, high-performance insulation and barriers. FG Glass is a value-added glass processor out of India. We have Focky. Focky are one of the leading curtain wall manufacturers out of Italy, present here in North America. Glassbell is a value-added glass processor out of the Baltics. Guardian Glass needs no introduction, high-performance glazing solutions. H.B. Fuller, who have acquired Comaling Chemi, again a ceiling bonding manufacturer. Hoffman Facades is a stone come high-performance cladding solutions manufacturer. Kingspan, again, high-performance cladding solutions. Curare, laminated glass interlayers with their brands Sentry Glass and Throsifol. LSI Stone is a Portuguese stone manufacturer. Mitrex and their sister company Clarify. Mitrex have BIPV solar cladding solutions, and Clarify has rain screen solutions. Canadian company. Saflex, part of the Eastman Group. Interlayer manufacturer, laminated glass interlayer manufacturer. Tremco, again, sealing and bonding solutions. Turkish Glass is the association of glass processors in Turkey. I have one slide which is corrupted. Who am I missing? Okay, that's Vitro. I'm sorry. The slide's cut, but I don't know what went wrong. But Vitro are, again, a high-performance glazing manufacturer. Our networking partners are Walter P. Moore, so they are sponsoring the networking reception post the event. And our lunch partner is Ornamental Metal Institute of New York. So these are our event partners. Of course, we've been approved by AIA for 8 LU HSW credits, which after the event, you can fill up your form and give your number at the registration desk, and they will process your points with AIA. Moving away a little bit from facades, glass was all these years a wonder material for architects. Timber is now the next in thing. Mass timber is picking up a lot in North America and in Europe, but we wanted to do something different, wanted to do a niche within a niche, so mass timber itself is a niche. So we decided we'll go ahead and do a timber envelopes event. So we're doing our first event for the mass timber industry, especially focused on timber envelopes in probably the worst place in the world to do an event on timber given the fire regulations, which is London. But it's a little regressive market when it comes to the use of timber in the external envelope, but you have a lot of designers over there who are designing for projects globally, and we wanted to start off with an event there. So it's basically focusing on the usage of timber in the building envelope, which is the roof, facade, cladding, ceilings, doors and windows, curtain wall systems. So this is something new, and eventually we will be bringing this to North America. It's going to be very different from what we have done. That's just because there's so much happening with timber around. So that's it from me. I'd like to introduce our event host and convener who's going to take you through till the end of the day, Attila Arian. He's the president of Schulte USA. He will be leading you through. Again, for those who've attended the event the first time here, I just want to explain to you. So we have a plenary session. So session 1, session 2 are plenary. So it's the full hall here. And post-lunch, the hall is going to split into 3. So you have one partition here, one partition here. So gallery A is going to become track A, gallery B is going to become track B, and that's going to be track C. So that's track A, this is track B, and track C. You can pick and choose your tracks whichever you want to. You can switch between tracks also if you want to, but seating is based on first come, first serve basis. So that's it from me. I'd like to thank all of you for being present in person. Really appreciate your presence here. It's been a horrendous year for almost all of us, and slowly we're trying to bring things back to normal, and your presence here in person is a statement towards one step towards normality. So thank you all. Over to Attila, who will take us through.
Good morning, everybody. I promise to speak slower than my predecessor and have less information for you to digest right away. Warm welcome also to our European colleagues who we have missed so much during the pandemic, who have been, thanks to God, on board to enter the US again. That's a wonderful opportunity for us to all leave the virtual world for one day and mingle in person and watch how everything is back. We are all back, and we are seeing also this city, New York, do what it is doing best, reinvent itself. I doubt that we will go back to what we had pre-pandemic, but we will open a new chapter, and this is a renaissance, and we all have the option to be part of this. The program today is all about New York, and all of you know that we have these 2 very interesting legislations, the Local Law 97, which by any stretch of the imagination is the most ambitious legislation as it relates to building emission in the world. There's no other city that has been introducing something like this. And the second one is local law 15, which is the bird-friendly glass implementation, which also is said to be the strictest when it comes to the requirements and the simplest when it comes to its implementation. So we have a great program for you today, and if you don't mind, let's get started. Our first speaker is what I would refer to as the German engineering soul who's watching over all of us. Zak Schulte of Arab will be speaking to us about the pain of getting it right and departing from the principle that we use in the US, design your best and hope that silicon will do the rest. Dirk. Thank you.
It's Markus. Attila, thank you so much for having me. Dirk is obviously somebody else, but I love Dirk dearly too. So, as you can see, I'm Markus Schulte. I'm a principal with Arab. I've been here in New York for 25 years. I joined them from the Berlin office in '93. We have a fairly large office in downtown Manhattan on Water Street with around 500 people. By nature, we are a multidisciplinary firm. I lead the facade group, but what I'm going to present to you today is obviously not my singular brainchild. It's the result of a great group of people who I've had the luck to work with over the past 25 years, really. And the projects that I have been able to do, you may obviously remember them all. And they all have very different issues. And when I came into this country, the project that was for me really important is this one here. And just to avoid any misunderstandings, it's obviously not an Arab project. As Attila knows, I studied at the Leibniz University in Hanover, and I'm kind of a child and student of the School of German Lightweight Structural Engineers. And this project was very important because it provided an important counterpoint for Germany as a country to this stadium here. So Munich obviously was free space, free form for a free society, Günther Behnisch being the architect, Fritz Leonhardt the engineer, Frei Otto who moved in the space in between the two, but it was in its incarnation, it was really I guess I can't go back. The Munich Olympic Stadium was really meant to be a counterpoint to a very dark history of Germany. And anybody who may have seen the movie Race, so this stadium is where Hitler didn't shake Jesse Owens' hand, and where Goebbels then in the movie refers to Jesse Owens as it, as a thing, completely dehumanizing. What that then led to is obviously all something we hopefully remember. And when January 6 came around, my 88-year-old father, who was born in 1933, he asked me, Markus, what are you going to do? And it's obviously he really gave me the question back that I had asked him as a young German, hey, Mama, Papa, how could Germany could have killed millions and millions of people? And obviously it's something that Germany as a country wrestles with to this day. But the interesting thing is, obviously, what are we going to do at this moment in time? For my parents, certainly, they feel we are at a similar moment in time, where we as designers, architects, engineers, scientists where we are being charged to kind of tackle the important problems of the world. And as I'm standing here as a father of twins, obviously at a point in time I will have to report to them, hey, what did I do? I will have to hopefully report to their children, what did I work on? What did we do? And I think the good news is, I think as technicians, as designers, as creative minds, we are best suited to wrestle this moment down. And the projects I wanted to share with you are two projects, obviously, that I'm very proud of, but I wanted to point out a few things here for our discussion for today. And so these moments, where are the Munich Olympic stadiums of the future, lead a little bit to what can we do with a large body of existing buildings, the brutalist buildings, institutional buildings, high-rise buildings, that were all created and built at a time of the nuclear age. Energy was supposed to be too cheap to meter. No worry of global warming then. Disease yields, so projected onto our society today, I guess that didn't quite work out either. Then the project I wanted to share with you is dates back already. It started in 2015, and a number of people know it. The point I wanted to make is relates to thermal performance and how thermal performance in current building codes is potentially evaluated. The Rockefeller Group as the client at the time, Chris Brill-Edwards, Jonathan Bursch, Dan Bauer, they had the foresight actually to reclad this fairly large building. It's 48 stories, 2.1 million square feet. The original architects were Harrison Abramowitz, Wallace Harrison, Paycop Fried, Mike Flynn, Kate, who's presenting later. We all worked on the project. And we, Arab, we provided a package of services. If one looks at the building, it's to some extent it's a celebration of efficiency. It does not have the typical 30-foot column bay for an office building, and it's fairly narrow. On the what you see in elevation here, this is a very narrow vision field, and then there's a very large spandrel panel. On the exterior, you see these uninsulated risers going up and down the building. And if you look at into the spaces on the inside, this very narrow vision field leads to very limited daylight penetration. So you can see the new design, one of the goals is to improve daylight penetration into the building. If one wrestles down and wrestles with a building of this typology, if you look at the existing condition, you recognize actually that there is no insulation. There's a 1/4-inch piece of glass for the vision area, and there's a 1/4-inch piece of glass in the opacified spandrel areas. No insulation whatsoever. So if one wants to improve it, what one needs to do is one needs to push out the building envelope, the exterior face of the glass, in this case a little bit more than 6 inches. So here we have now an improved vision area, and we have our insulated spandrel area. This pushing out of the facade leads to that one triggers a zoning review, because the gross square footage on the lot increases. It's counted from the face of the facade. And one is only allowed to meet or to push the facade out and add this square footage to the lot if you meet certain specific thermal performance requirements. And what one does and what we do to prove that we meet the thermal performance requirements stipulated by the zoning regulations, we calculate first here the performance of the existing facade with a program called Therm. That's what we nerds do. And then we tabulate it. And this is an interesting summary of the important thermal performance criteria on this building. It's not only U value that is important. Solar heat gain and air infiltration are equally important. In our current code discussions and ICC's equation 4-2 being used as a backstop calculator, the solar heat gain and the leakage criteria are completely left out of board. So it's fetishization of U value that is happening right now, which I'm not necessarily a friend of, as you can gather here from me talking. The other point I wanted to make, so the U factor improvement per zoning regulation that is required was 63%. We were only able to achieve 42%. But then you can see the other items, solar heat gain and air leakage. We obviously improved the performance of the building significantly. So at the time, what we did is we did a whole building energy model. And what you can see is that thermal performance improvement in U value, solar heat gain, and leakage is not linearly proportional to energy savings. So the way we got this project approved is that in the combination and looking at all the different items, we proved that actually our facade is performing much better compared to if one would improve the baseline alone. So in this case, you can see the facade improvement saves 23% of energy in this building, and in combination with the upgrade of the perimeter induction units, we are saving something like 31%. Huge opportunities for energy savings on buildings. The central mechanical plant on this project was upgraded a long time ago, and so these borderless buildings, they offer huge opportunities for us as designers, as engineers, to contribute to reduction in greenhouse gas emissions and to reduce global warming. And you can see this is the summary of it. The next project I wanted to share with you is a different animal. Interestingly enough, the Metropolitan Museum of Art, at the beginning with Tom Javits, now with Yellen, have engaged on upgrade projects on their large existing building. And this project is a project on the southern side of the building. It's this wall here. It's the Arts of Africa, Oceania, and Americas Gallery. It's the replacement of the sloped glazing on the southwestern side. The architects, the executive architects are Bayer Blinder Bell. The exhibition architects are Y. And we, Arab, we provide facade consulting and lighting design. Colaronen are the mechanical engineers, and TT are the structural engineers on this project. You can see the gallery is here on the western side. And if you look at the original Roche Dinkeloo drawings, you can see that this 4-story glass wall was implied to have a connection to the park. And then there was a little bit of opacity implied in the glass on the upper registers. Obviously, then for the institution, having a 4-story glass wall for the exhibition of very sensitive, conservation-sensitive artwork is not an easy proposition. So if one looks at the project, when the project opened, the shades were down immediately, and a solar control film was attached to the glass. So you can see 40 years later, the institution has been wrestling kind of with this wall for a long, long time. The goals on this project, obviously the Met doesn't upgrade their building very often. And some of the goals that are shown here are potentially in direct conflict with what can technically be achieved. And obviously, you're kind of establishing visual sightlines
by keeping sunlight and direct diffuse light out and managing the quantity and quality of the light is a very schizophrenic proposition to begin with. And you can see client and designers very much kind of focused on establishing this visual connection, potentially to the detriment of the artwork, where conservation of the pieces that are there have to follow very strict requirements. And that does not only relate to, in the context of the overall quantity of light, but obviously then the quality of the light as well. In this case, UV. And then in color temperature, getting that right, the support lighting of the electric lighting in the exhibitions, getting the color rendering right, getting angles and visual comfort for the patrons right. A lot of design criteria that come into play to make this a successful space for the patrons of the museum, while at the same time protecting the artwork. And then obviously with some of the board members supporting the Audubon Society, Local Law 15 is obviously very important and relevant for this project, right next to the park and the trees that it has as well. So what do we do? As you can see, I'm standing here as an engineer, and if one is faced with a proposition like this, what one looks at, one obviously in the first step here, in this case, one looks at the light. And the graph that you see in front of you, that is the amount of light over the year for each month. The black cells are nighttime condition. The orange cells are direct sunlight condition. The blue cells are a cloudy sky. And then the dark gray cells are completely overcast skies. It just gives you an idea of the solar conditions at the location of the project. Then when you look at the project in plan, you notice obviously that it's following Manhattan's grid. It's shifted clockwise, and it beautifully faces the afternoon sun. So it harvests really the sun to some extent, the polar opposite from a north light system of what would want to do typically in galleries to assure daylight requirements. Here you can see now that if you go along that at winter, summer, and the fall conditions, there's absolutely no shortage of light. And in section, the upper red line is the summer solstice. You can see that the kind of the sun peekaboos around the corner here. It goes down, it goes over, and then comes back at very high sun angle. Then you can see at the fall and at the spring condition, it goes all the way over. And then at the winter condition, the sun is very low, and leading to potentially very deep penetration into the space underneath. Then what our lighting designers do now, they take the local solar climate and they project it through the facade into the galleries. And they do that to arrive at a strategy to manage the overall quantity of light. So they built their lighting models, and they come up with a strategy to meet the amount of light in plan and to limit penetration into the space. And what they do is they look in plan, they look at the artwork and define allowable lux hour levels that the artwork can experience. And then they modulate the VLT in the facade surface to arrive at the maximum allowable levels, which are these ones here. And so exposure and conservation of artwork, the most important criteria is the amount of lux hours in light it sees over a year. And then we, as facade consultants, we are tasked with this abstract plane of a facade. How do we materialize to arrive at a system that meets the art conservation criteria that have been coordinated with the conservators of the museum? And anybody who has worked on horizontal and vertical shading elements, you can see you apply shading elements, you tilt them, you make them bigger, you can see you reduce the exposure to direct light. And at a point in time, when you do this, you arrive at a situation that you, to some extent, you really want to combine the horizontal and vertical shading elements to limit the amount. The horizontal and vertical shading elements, unfortunately on this project, the project is landmarked, and you can't just plaster these in front of the Roche-Dinkelot design. So it becomes very clear if you want to create a combination of horizontal and vertical shading elements, that one strategy that one could apply would be angular selective glazing. These are the straws, the ochre capillar or the panelite systems. These can be used to manage the overall amount of light. And what it does, it creates a very distinct view. Obviously, you can see horizontal louvers alone, in this case, integrated into the glass, they wouldn't cut it, because as the sun goes around, ideally you would want the louver to go with it. And unfortunately, we can't do that here due to the landmark requirements. The other elements, and you saw that on the prior slide, that are available to manage quantity of light, PVB interlayers, the Van Siever interlayers, and ceramic frit. And the ceramic frit has the advantage that it helps in mitigating bird strikes. And Christine will be part of a later panel today. She has been fundamental in allowing us to mitigate bird strikes on this project. And then the other elements, obviously, that come into play is color rendering. So the colors of the frit, the color of the low E coating, the color of the glass substrate has to be chosen such that it doesn't distort the color rendering and the viewing experience of the artwork in the gallery. And obviously a lot of you, I'm sure, are using low iron glass. That is key. But then the color impact of the low E coatings and the color impact of the frits is very important in equal fashion. The last element that comes into play here is thermal performance. This project is different than 1271. Here, triple glazing does make a significant difference. It's a 4-story glass wall. For the comfort and for the local loads in the space, triple glazing makes a tremendous difference. And you can see it does not only help in the context of overall energy consumption, it helps with condensation mitigation. Museums, healthcare buildings, they're all humidified buildings and are driving at a fairly low dew point, in this case 50 degrees or 55 degrees. And you can see just the center of glass U value of a double glaze unit in this case would not allow mitigation of condensation in the center of glass. Lo and behold, then considering framing effect, transom sills and head details. The other important item is obviously module size. And the number of joints that one can have, the number of weak points, is very important. So here we arrived at a module size that picks the first transom above the plane of view, but it still creates a glass panel, a triple glazed unit that is not too heavy and too cumbersome for replacement in case a piece of glass breaks in the future. So where does this all go? Obviously a lot of options one can have. And this is an option that uses passive means for managing the quantity and quality of light. So Vancouver interlayer ceramic fret low E coatings. Then the next one is an electrochromic option. And then the last one is the integrated cellular panel with very distinct angular visual capabilities. All of these systems, in the context of system, can be applied in this case to a triple glazed stick-built cassette system. So the glass, you can see, comes with aluminum channels, structurally silicone to the underside, and then are toggled to a stick-built aluminum system. And what this creates, it creates a system without pressure caps on the exterior that are prone to leakage and are prone to the delta T to deteriorate over time. So we just have a silicone face seal, then we ventilate the glazing units all around its edges, and this network of secondary ventilation then is being drained to the exterior at the bottom. And then you can see, as in an effort to have belt and suspenders for condensation, we have condensation gutters, a channelized system of condensation gutters that collects any, in extreme nights, any condensation that occurs and puts it into a reservoir at the base. The finally selected glass is a triple glaze unit, and in this case it's a laminate on the exterior. You can see it's a 2-ply laminate, thicker on the exterior to make the unit bubble to the inside, to make the unit visually really flat. In row number 1, we have fret on surface number 1, and in rows 2 through 8, we have fret on surface number 2. In both of these have a low E coating. Trush is the glazing fabricator here. It's a 3221 combi silver coating, which works a little different here. Typically one wants to increase and maximize the ratio of VLT to solar heat gain. Here it is almost the opposite. We want to bring the VLT down and retain the color rendering. So this cuts a lot of light out, this coating, but it still maintains the neutrality of the glass so that the color rendering overall stays high. Then we have a simple fully tempered light in the middle and a regular PVB on the inner laminate. And for rows 2 and 8, we have Vancouver interlayers in combination with a gradient fret that manages the overall amount of light that the spaces experience. And this is, you can see, this is where we are right now. We built the daylight model, and we have been measuring it, obviously the amount of light that we have and the quality of the light that we experience. And so far, everything looks really good, and it meets the predictions. So we correlate what our computer models have been predicting with the actual mock-ups that were built at Caden in New Jersey. And hopefully then leading to a situation that the new galleries will allow a view to the park, while at the same time meeting the strict conservation requirements stipulated by the museum. And coming back to my initial is the other approach to projects, my approach, my team's approach, is that we don't try to impose ideas and designs on top of projects. We kind of look at the health of the project first. What does the project tell us if it could speak to us? If we analyze it, how would it look like? And with that, I think that is what we as technicians can contribute to this discussion about designing projects that perform better and where narratives, design narratives, have actually content and don't require a post-design engineering justification. And with that, I pass it on. Thank you so much.
Markus. I apologize calling you Dirk. It is one of those things that come with age. You start renaming people in a very persistent manner to keep your life simple. Very, very interesting. Thank you, Markus. We have a lot of very innovative, visionary architectural firms in the city. And one of my favorite ones is Shop Architects. I have been consistently fascinated with their holistic approach to projects, and we are very honored to have Gregg Pasquarelli here, who's one of the founders, to speak to us about authentic materiality. Gregg, if you would join us here, please, up in the front. Thank you very much. Thank you.
Good morning, everybody. If they had told me this speech was this early in the morning 3 months ago, I would have denied it. I'm not much of a morning person, so my apologies. So some of you may know Shop. We are from New York. We're a 200-person architecture practice here, and we're known as a New York firm, and a lot of our projects around that people know are in New York. But for the last decade, we've really been building around the country and around the world. I think the consistent thing between a lot of our projects is really talking about facades. It's talking about authentic materiality, about texture, about taking traditional materials and using latest digital technology to reposition those materials into different ways of seeing, of aging, and really taking a kind of strong position from when we first started the practice against the kind of all-glass building. That we've always felt it's really important that there's this ability to have texture, to relate scale, to think about the way materials age and patina naturally over time, and to have that kind of humanistic relationship between the body and the building. Some of the buildings you may know us for, things like the Barclays Center, made out of weathered steel, or the Pier 17, the American Copper buildings on the east side, government complex in Botswana, Africa, or some of our new projects. This will be the tallest hybrid timber and concrete tower in the world in Sydney, Australia, the new embassy, U.S. Embassy in Bangkok, a new tower in Rotterdam, and the new consulate in Milan, all with these kinds of sort of exploration of materiality and texture and connection with history that we think are incredibly important. But today I'm going to talk about 3 projects, 2 of which are here in New York and 1 in San Francisco, starting with 9 DeKalb. But these were all projects where the facade was really incredible and integral to not only the way the building is read and understood and performs, but also in getting the entitlements for the building. And so therefore was a key driver for the project. This building was a really tricky project. It's at a triangular site at the corner of DeKalb and Flatbush next to Fulton Street in downtown Brooklyn. We had a landmark bank that was taking up 2/3 of the site, and this was a building that was both an exterior and an interior landmark, which was a magnificent space. And here we were challenged with deploying 800,000 square feet on top of a site with a very small footprint to land the building. We looked at some of the details. It was the dime savings bank, these incredible mercury dimes, and the capitals are fantastic. the original architects really had beautiful use of materiality and color that we used as a kind of driver for thinking about the project itself. And then we looked at how the original architects dealt with the triangular site using a series of six-sided stars and hexagons in order to deal with that geometry and sort of position the building in its site itself. So the dark blue line is the exterior landmark, the light blue line is the interior landmark, and then we just had that sort of small area to drop the building, and we could have, as of right, built a sort of very large, tall slab building that would have blocked the landmark from the main Flatbush Avenue address. What we decided to do was sort of take that triangulation and drag it across the site, and then ask for permission to demolish the back part of the landmark building, leaving the interior portion of the landmark alone, but then to sort of create a series of interlocking hexagons to deploy the FAR into the tower itself. Now, when you're building in Manhattan, you've got the sort of avenues as the primary streets and the streets as the sort of secondary, and so there's always a kind of positioning of the building and the way it sits. By building what we knew was going to be the tallest building in downtown Brooklyn and also the first super tall building outside of Manhattan, and the only site that was zoned to allow a building of this height, we knew that the building would sort of stand alone on the skyline and would be viewed from all the grids in Brooklyn, which are actually not aligned. They're all different grids because they were built at a different time. And so the goal was that no matter where you saw this building from a distance down these kind of one-point perspective avenues, we wanted to make it feel like you were looking at the front of the building, if you were. So we did the series of setbacks in a kind of spiral. We started doing some research on this notion of fluting, both in nature, in historic architecture, and what an idea of contemporary fluting would be. We used a series of sort of colors drawn from the bank, everything from a kind of black stainless steel, anodized aluminum, a bronze alloy, a baked enamel. And we extracted literally thousands of different shapes from the historic bank and began to we made these boxes and we began to just sort of assemble all these different combinations of extruded tubes that were abstractions taken from the bank in the different colors. We took a light, dragged it across it, we photographed it, we saw the kinds of patterns and systems that we thought were interesting, and then that became the kind of texture on the facade itself. And then it changed from sort of lighter as you were lower in the building to darker as you went higher in the building. And then these were some of the models where we were working on the interior of the building and the exterior of the building and moving the inside to the facade and switching it around. You can see our very high-tech binder clips up at the top, keeping them in place. Oops, sorry, I went one too many. And I think that what we were trying to do with the hexagon and with the texture was that the most interesting thing about a hexagon building is that you're always looking at two facades in the oblique. And while this was mostly a residential building and needed a lot of glass, we wanted a building that had a certain solidity, something that earned its position on the skyline and felt like this kind of landmark or this lighthouse, whatever it may be. And that by having this kind of incredible texture on the facade and looking at it in the oblique, it would turn those two facades solid even though they were glass when you were looking at them. And that was really the driver behind the design of the building. So here's the model. We had to, you could see the building as it went up, and then we had to finish out the rest of the base that connected to the landmark bank. We had about 3/4 of the site. The one corner is the one to the bottom left. Some of you who know Brooklyn very well, that's Junior's Cheesecake area. I really wanted to knock Junior's down, but I think I would have gotten in a lot of trouble with a lot of people from New York. So again, we now had this very tall building that had to relate to the base. We needed landmarks approval. So we said, how are we going to finish that base and have a completely different facade that was something that you read at the street? So we looked at the existing facade, and we saw that there were both these convex and these concave notions of fluting that were apparent throughout the building. And so we said, what if we took those two things, the convex and the concave, and created what we call the convexicave pilaster, where we took a 65-foot high pilaster of marble and 5-axis milled it out so that it went completely from the convex to the concave along the piece, and then used those to establish the rhythm of the fenestration around the bottom. So here you can see the details where it goes from a convex to a concave, how it turns the corner at the main entrance where you see the building as you're coming down Flatbush Avenue off of the Manhattan Bridge. And then it's all bracketed. It's bracketed by these bronze elements that go together on top of this black marble base at the bottom. So here you can see the view as you come down the road. Here you are on the entrance on Flatbush Avenue. And then we took the roof of the landmark building and created the sort of amenity space for the residents themselves, and centered the pools around the landmark dome. It was a complete restoration of the historic building. We created a second entrance by preserving the facade of the landmark building on Fleet Street around the back. And then you could see the demolition of the back of the landmark building, but leaving the interior landmark, which you could see as part of that hexagon on the right, digging out next to the subway system, and then pinning the landmark wall as it wrapped around, setting up the space for the tower to be built. And so we really kind of loved this idea of the way in which the building would be viewed from Albee Square, which is a great pedestrian square, and then what the building would look like when it was done as the first and only super tall tower outside of Manhattan. And so here you could see as the facade panels arrived, I mean, they're kind of this almost oddly both modern and Baroque facade at the same time. It was really important to us to sort of hold solidity at the corner and create these patterns of light and materiality as it turns. And the building is under construction. We topped out the superstructure about 2 weeks ago. You can see the facades going up. You can see the solidity when you look at the facade along the oblique. You can see the reflection. It's a super dark glass. We were really kind of interested in this building that sat opposite the landmark below. Ellick was our facade manufacturer on this. M.W. Skins was the engineer. Here you could see right as we were topping it off, some views of the building as it sort of sits on the skyline under construction, and a kind of remarkable view of the city that one doesn't normally get from the residence in the top of the building. Remarkably, this building was approved in one session at Landmarks, and one unanimously approved by the community board. For those of you who practice in New York, you know how unusual that is. One of my most proud moments was when the Landmarks Commission said, "Thank you for giving us buildings that we can landmark in the future." But again, a building that was really driven, its performance is driven, whoops, one too many, by the facade, and it already has a kind of remarkable ability as the sun passes over to turn from this sort of very dark, brooding building to this kind of shimmery gold building. It has this solidity, yet it has this incredible glass and this incredible views, and is one that we'll see be finishing in the next year here in New York. The second building in New York I want to talk about is 111 West 57th Street. Some of you may have seen it going up, but I wanted to talk about why the facade was such an important part of the design itself. You know, we knew building these sort of tall buildings, it was really thinking about, this idea of the kind of low fabric and the soaring tower is something that is really a part of New York, and really, really important. But yet, I mean, I think there was a lot of derision, a lot of criticism about some of the soaring towers that were going on, and so we wanted to know why, because we didn't think it was the height, we didn't think it was anything like that. We just wanted to really think about what are the towers that New Yorkers love, and these were some of our favorites and some of New York's favorites, and of course these were all buildings that were built as commercial buildings, but pre-air conditioning and had narrow floor plates, and it was really about the proportion, and that those buildings gave a certain silhouette on the skyline. And so we were really thinking about proportion because, post-World War II, the 30,000-foot floor plate, air conditioning, they give a very different kind of building, and we like these buildings as well, but it's just, some of them are some of the best buildings ever built. But it gives a very different sort of silhouette on the skyline. And as we know, these last few super talls that are using up the last FAR in Midtown are giving a very different silhouette to the skyline, but one that's obviously driven mostly by residential, which is really about gaining the view of Central Park, which is, from a view perspective, kind of the last gated community in the city. Now, our building was really remarkable in the sense that the floor plate was only 60 by 80, which sounded incredibly small, one apartment per floor. Remarkable, but when you look at the Chrysler building, it's only 90 by 90, but no one really thinks about it as being that small. Obviously, incredibly different than a typical post-war building of 150 by 300. We also had a landmark to deal with here, which was Steinway Hall, a Warren and Wetmore project built in 1924, where for basically a century Steinway pianos were sold. Really a pretty fantastic building, which is an L shape that was wider on 58th Street than it was on 57th, and then there was a vacant lot next to it that our client bought. So our client bought the vacant lot, they bought Steinway Hall, and they bought all the available air rights that were left on the block. For those older New Yorkers, you'll remember the Ritz thrift store used to sit on that site, which had great commercials a long time ago. Well, I don't know why that's not reading, but this was also both it was an exterior landmark, and we proposed to make it an interior landmark as well, by landmarking and restoring the existing building, which was in pretty bad shape by this time. And so we could have put all of the FAR on the vacant lot, which would have kind of obliterated the top of the Steinway building, which we thought was pretty magnificent. And so what we proposed to do was to build the tower on top of the landmark, but shift it back and around and sort of celebrate the Warren and Wetmore building itself. And so we had to build 65 feet high on 57th Street. We created this retail podium. There was an amenity level. We took every other floor out of the Steinway building to raise the ceiling heights for the residential units below, and then started the tower above the Steinway portion, which then reaches up to 1,428 feet. So here you could see the facade as it comes down for the retail podium. We brought some of the elements of the facade down to the street because I thought it was really important that people could touch them, and then deployed that building at 60 feet wide by 1,428 feet tall. So for those of you who know slender buildings is any building with an aspect ratio of more than 1 to 10. Anything that's more than 1 to 15 is considered exotically slender. The most slender buildings in the world are about 1 to 18. They're mostly in Hong Kong. This building is 1 to 23 and a half. So really remarkable structural engineering feat that WSP designed. And then you could see we fully restored the landmark Steinway building and then nestled the tower as it came down. And then when we were thinking about the design of the building, we were really looking again at the notion of the setback, and could we rethink the concept of the setback. And the traditional setback is on the left. The sort of way many people are dealing it with today is kind of rotating the sky exposure plane back. And we said, was there a way to do both of those at the same time? And so it was this notion of the feathered setback, that there would be multiple small setbacks that sort of followed the sky exposure plane to be a sort of both-and condition of a traditional New York skyscraper and a modern one at the same time. Every floor has its own, it's a single apartment. So we sort of loaded the structure in the east and west facade and opened it up to the north to the park, to the south to the city. We put the living towards the park and the sleeping towards the city. And so, like I said, it's a single apartment per floor with elevators that open right into it. And when we started to think about the facade, we were thinking again about this idea of something that looked at history but really pushed it forward from a technological perspective. It was that notion of texture and materiality that led us to a terracotta facade. We had these monster shear walls, basically 5 feet thick, by 70 feet long. The structure is basically an I-beam in concrete with small punched windows in the east and west. But instead of having a sort of super blank wall, we said, what if we were able to create a kind of texture on the pilasters, each pilaster ending in a setback itself? And if we could do that so that when the sun hits the building from the south and you're walking on it and seeing that side facade as you walk on 57th Street, it would create this shadow and light moire pattern on the facade of the building itself. So the profiles are 26 different shapes that when they're installed rotate back and forth. And then there are 6 different colors of cream, which creates 42,800 panels of terracotta. That here you can see some of the studies, some of the full-scale mock-ups. And then the extruded pieces made by NBK out of Germany. And then here you can see the rendering of those terracotta pieces and the bronze filigree that kind of give it this sinewy tissue between these sort of strong vertical elements. You could see some of the visual and performance mock-ups as we were testing it out. And then seeing the facade as it goes up on the shear wall on the building itself. Looking east, this is from Fifth Avenue. This was the rendering of what we expected the patterning to be like when you looked at that building. So again, instead of looking at a kind of flat party wall, you suddenly get this really magical connection of texture and shadow and light and materiality. The north part of the north facade, which was facing the park, was mostly glass. We sort of did these inset bronze elements that change in their dimension along with the change in the glazing panel size as it moves towards the middle to almost give it a sense of curvature. And each apartment has a 60-foot living room facing directly onto Central Park. No, this is not an affordable housing project. And then here you can see it as it's built. As I like to say, you've got the best front yard view you could ever imagine, and you never have to mow the grass. But then taking those facade elements and moving them on the inside, there's even custom lighting elements that are all derived from the facade system. And then maybe my favorite part of this entire building, which is we made custom door handles, which are the building itself, that we cast at P.E. Gurin down in the West Village. And therefore, every time you open or close the door, the building itself is in your hand. The facade was also a generator for some of the duplex apartments, and these are the way the buildings are delivered. We reused the curb cuts and the loading docks from Steinway Piano to create an interior porte cochere along 58th Street. Again, you could see the tall building. You could see the building under construction. And here you can see the facade as it starts to come on. Now, and then if you look at this one here, you can start to see the light and shadow as it bounces off the terracotta. Looking at it, this is from 6th Avenue. And one of the things that I think is maybe my favorite part about the facade itself is that, an all-glass building sort of accelerates the wind as it goes across it. It's basically the same as an airplane wing. But the texture on the terracotta actually creates turbulence as the wind comes across and slows down the acceleration of the building and the movement of the building. We do still need an 800-ton damper, which is at the top of the building. I was up there the other day in a windstorm. It works. We'll see when it's really windy how it does. But again, here you can see the building as we're nearing completion of it. Where the facade comes down, turns the corner to the all glass to the north, but connects with the landmark building below. Looking up at the building, Buer Happold was the facade engineer. Here you could see the tower top and the building looking at Central Park. SYP was the glass manufacturer. And looking at it as one of the new towers on the skyline of the city. I'll finish up on the last building, which is a project in Mission Bay in San Francisco, which is Uber's new headquarters. a really interesting project where we had 2 sites across a park down near the new basketball stadium. Bob Heinches were the engineers. Joseph Gartner and Perma Stelisa did the facade. Glass was by Interpane. But, you know, the interesting thing, we do a lot of work for tech companies, and, you know, they always want it to be a sort of campus. It's funny, the tech companies are always looking at universities are always looking at the tech companies, and they're both looking to hotels on how to actually, hospitality, on actually how to make their projects work. But what they've realized in the last decade is not to be out in the suburbs, but how do they get a campus performance in an inner city location. And so it's been this idea that we've been working on about sort of folding the campus into an urban vertical campus. And, you know, again, looking at San Francisco and the verticality of San Francisco, the idea of the building was to figure out a way that you could put all the collaboration spaces not deployed all over the building, but focus them into the 2 facades, the south and west facades, and to make it all connected by stairs, and to be able to get to anywhere in the 2 buildings within 6 minutes of walking. And that the idea was that the building, this is a sort of typical section, that the front third of the building would be all the collaboration spaces and would be not air conditioned, that it would be outside. And that the back 2/3 of the building would be air conditioned, and that's where the programming happens, but all the collaboration happens in this front porch. And so the facade really went through a lot of issues about how we can make it as clear as possible so that you could see in. The CEO of Uber sort of talked to us about, everyone thinks about our company by looking at their blank screen. We want a headquarters where they can see inside, where they can understand and see what's going on, and that the collaboration of the people that work here actually occupy the facade itself, so that the vertical campus, the quads, are in the thickness of the facade of the building. And so here were some of the concept images of what that might look like, of what we call the front porch or the commons. And now the building, they are just moving into it now, so here you can see it as it was finishing construction. Obviously, it was really driven, and the whole design was driven around a sort of thermal and environmental performance. There's a huge amount of biophilia built into the facade itself, which is a pretty incredible thing. So here you can see, to create shading, it's a fully integrated irrigation system that helps create thermal comfort and shading, and works on the sort of moisture in that front open facade. And here you can see in the commons, and what this looks like. The sort of interior facade really is more like it's a curtain wall, but there's all this natural ventilation coming in, and so there's a sort of wood screen that helps protect it from the outside. It reflects white out and black in to cut the glare on the screens. And then here you can see some of our other performance analysis, and then what the building looked like in and of itself. And I think the most interesting thing about the building is that wherever the facade wraps around the commons, you have a series of bifold facade elements. So these are 10 feet wide by 14.5 feet tall. There are 180 of them, and based on sensors and what's happening in the common space, they automatically open and close and let the building breathe to control the temperature, to control the wind, and to control the environment. So you literally have a living, breathing facade that opens and closes the building. I had a video, but it didn't work. Sorry about that. We're so technologically advanced. But this incredible clarity looking in is really pretty remarkable, and they're all operated by 2 fully concealed chain drive actuators. It's all controlled by the building maintenance system. And then you could see the kind of bridges that connect the 2, with a kind of mirrored facade around the bottom that reflects the park below. And then looking across these bridges and up at them. And then the bridges are really, even though it's 2 bridges, it's 4 connections, because you walk inside in the bridge or on the roof of the bridge. and then looking through that incredible facade and at the building itself, I find they're moving in. Everyone's sort of now just finally, they were very quiet about the building for a long time. Everyone was sort of now looking at it, and they were going like, that's the greatest response for COVID I've ever seen. And I'm like, yeah, right, designed in 2015. Yes, thank you very much. Anyway, we're unbelievably proud of the building. Another way to take materiality, natural materials, contemporary materials, thinking about them, thinking about what it means to do a glass building, a living building, a breathing building, or a building with those kinds of textures and materiality that connect both to the past and the future. And we're very proud of them, and thank you so much for having us here today.
Thank you very much, Gregg. When you are a supplier or a contractor, you quickly learn in your career to respect facade consultants and appreciate the consultants who work and collaborate with you with practical solutions. One of those firms in this city is formed by the legendary Bob Heinches. And we will have our friend Daniel Voss speak to us today about visions of high performance.
Thank you very much. Good morning. Thank you for having me. It's a real privilege to get to speak at these conferences. We really enjoy the opportunity, and welcome all of you. So yeah, today I wanted to speak about opaque facades. So we've worked on many, many facades around the world. Let's see if I can work on my cues here. Yeah, good. We're a facade consulting firm based here in New York. We have an office in San Francisco. And really what we love to do is help architects and engineers build amazing buildings. So we've worked on some train stations in the area you might recognize, tall towers that might be in the vicinity as well, unitized curtain walls like the renovation of the United Nations Secretariat and General Assembly and all of the accompanying buildings. Nice residences in exotic places for us, at least. This is a tower in Singapore, Reflections. And small institutions like the Smithsonian, the National Museum of African American Art and History. Oh, yeah, perfect. Okay. And the Whitney Museum, so civic institutions, amazing for our cities, as well as corporate headquarters, which Gregg just nicely presented. So this is one of our favorite projects too. Really took advantage of the amazing San Francisco climate, which yes, many of our office members enjoy too. And flagship facades like this one, the Nike facade, which often lead to amazing instances of innovation. So big opportunities for facade work. But today I want to talk specifically about opaque facades. And I think, you know, as Gregg's presentation brought in quite nicely, I think this keys right into it. There's been a lot more interest from architects and from owners in the opacity of facades. And I think there's a reason for this. There are lots of good reasons. One is architecturally it's very interesting, right? But there's also an energy reason for this. So just to set the context, step back for just a moment, want to think about where buildings are in our energy spectrum in the world, right? So this is the International Energy Association from the UN, documenting that about 36% of energy use in the world comes from buildings. So 30% of that is actually in the operations of buildings, and 6% from the construction, so that's the embodied carbon content, right? So that leads to about 37% of emissions, and 10% of the carbon output is from the actual construction, where 27% is use. So think about that, is that there's a lot of existing buildings out there, but the more that we can build efficient buildings, the better we're going to be doing. So the International Energy Agency, again, has a nice idea of how this could happen. So working from 2020 towards 2050, what we really need to do is lots of things, right? Of which energy efficiency for buildings is a big part. Electrification, huge, probably even bigger than what we can do in the building industry. but from our side, we're looking at energy efficiency. So where does that happen? How does that happen collectively? And so I think this is where it's really important that we embrace the changes of building codes that are coming our ways as architects, designers, contractors. I think all of us have the initial reaction of something's new out there, this is tough. But actually what it's doing is it's driving collective action. So this is something that's set up, really, if you go back, and there's a very interesting history of where international building code came from, starting in the 1990s, working through, and we're seeing the benefits of that program now. So you can see here where we have developed countries with energy codes, we're actually reducing the energy intensity of buildings. And this is very important because we're building more buildings every year too. So the more efficiency critical. So just thinking about New York as a microcosm of this effort that's going on around the world, you can see from 2009 when we adopted the IBC codes here in New York to 2020, how we stepped along with the ASHRAE's performance from 2004 to 2016. So each new building code required more stringent metrics. And still, so here we baseline it with 1975, so we're about 50% of the energy intensity use of a building now that's code compliant, simply code compliant, than we were in 1975. So this is great. We're pushing this collective action just by being code compliant. Nicely in New York, we have stretch code, so it actually pushes us just a little bit further past that. And today I want to talk about one further program, Zone Green, which I think, Markus, you were alluding to in one of your projects as well, that really brought it one step further. So aspects of these codes is that it's going to improve overall performance. One of the main ways is opaque areas. So this is a studio gang project we worked on in San Francisco with a window wall unitized system. Here's another one where the choice of material was terracotta on a unitized curtain wall. So really, again, thinking about how architects are focusing on the materiality of the opaque areas and how that's becoming a real expression of the building. Or with Ramsa, Bob Stern's office, including stone panels on a super tall in the middle of Manhattan. So challenging architectural exercises, but again, the character of these buildings is really coming from the stonework. Zone Green, zoning initiative. So there's a little screenshot you guys can go on to find the zoning code. An interesting initiative that's pushing further thermal performance. I think especially thermal performance. So the key here is owners, developers, they can get an extra 8 inches of FAR discounted from the thickness of the facade if they hit a couple targets. 20% better than code for opaque areas and 10% better overall for the entire facade vision and opaque. 20% better than code in opaque areas also means that you actually have to count your opaque areas as opaque areas. So this is a loophole that used to be followed in the curtain wall industry where spandrels were considered not opaque, but important to consider that. So this is pushing us to a paradigm where we think of building envelopes a little bit like this, that we have an interior and we want to create this shell on the outside, and the mechanical engineer's dream, this is what they're asking us to do every day, is to create a thermal envelope such that nothing gets in from the outside and nothing gets out from the inside, right? They want to control all of the intakes and exits of energy through the building. They're going to create the controlled environment. We protect them from the sun. They exhaust heat energy from the inside when it gets too hot. I believe when this works, right? But this is a big question for the building industry that we have to kind of keep working on and making sure that we're accurately modeling our buildings to make the right choices here. So the beauty of Zone Green is the building owners get extra floor area, right? So that's the incentive program that we're looking at. But let's talk about some numbers, just what that means for the facade. So at the top in gray, you can see our typical vision spandrel code compliant building would have U factors of 0.36 and 0.061, current code. A high performance, and these words get thrown out there, right? High performance, ultra high performance, whatever it may be, but 2015, that would have been a 0.35, so just a little bit better than what we ask, and a spandrel of 0.25. So well about a factor of 5 times worse. And you can see that we fail in the ratio to code. generally that was taken up by mechanical systems, right? So the mechanical systems had more ability to meet this, so you could meet energy code with these numbers. High performance now, the zone green vintage 2020, so projects that we're working on are aiming for numbers like this, 0.23 for the vision area. So this means triple glazing, and it means very, very good frame values. And the opaque area prescriptively has to be at 0.049, which in the worst case, and we don't recommend doing this, we don't do this, would mean just putting insulation on the inside of your facade. In the best case, you design a system that works, and so I want to show you what that would be. What it also means, though, generally, is that you're going to have less window and more opaque area, which is why the opaque area is becoming so important. So this is just an example of what a 60% vision glass building might be, right? White vision, blue opaque area. If you just scale it down, you get the building next door there with much more blue. And so that's really why architecturally the opaque area is becoming so important for architects to control. So think with me just what thermal performance really means, right? Heat pressure inside a building wants to get out in the cold winter. So an analogy for that would be something like a bowl of water. And if you put a lot of holes in it, this is your leaky air, leaky thermal performing building from 2020, let's say 2000, right? Pre-2000s. What that means is you need to input a whole bunch of heat energy at the same time, right? Your faucet's heat is running into the building. I think we've gotten in 2015 to that bowl in the middle, right? We've